Okay, so this is chapter 6 is about geometry. So geometry is about some shapes, some geometry shapes. So we have 2D geometry shapes and 3D geometry shapes. So for 2D, we have like a triangle, square, a circle, like a tangle, those things, and some polygon. Okay, and for 3D, we have a cube and a sphere and a coin and a cylinder and a pyramid, those things. Okay, so let's start from triangle. So triangle is formed by 3 sides and 3 angles, like just 3 sides. So we have a triangle. So let's say we know this what has point as A, so B C. So we say triangle ABC, and this side A, so angle A face side A, so ABC, and we also can denote this angle as alpha, beta, gamma. So we want to start the relationship between those angles and those sides. So for angles, at first we have this alpha plus beta plus gamma is 180 degree. Okay. So for degree, we define this angle turn around one circle. This degree is 360. Okay. And the 180 is this angle 180. So we also can call this 180 as flat angle. And half of 180 is 90 degree, right? So we call this as right angle, 90. So, okay, so this is right angle. Okay. So at the first, we have some notation for angle. In terms of, so we want to find the degree for some angle. So let's consider this problem. We say, like, let's say we want to find an angle, number of degree in the smaller angle between the in a clock between the hour hand and the minute hand when time is 7 o'clock. So when time is 7 o'clock, so we know 7 o'clock. Okay, so here so 1. Okay, that's so here 12 o'clock or 0 o'clock 12. So here's 1, 2, 3, 4, 5, 6, 7, 8. So okay, 9, like 10, 11. So there's a clock. Okay, so the time, the 7 o'clock is the minute, hand is here, and our clock is here. So we want to find this angle, right? We want to find this angle. So this angle, we can split this as, okay, like this one angle, right? Okay, so 1, 2, 3, 4. 1, 2, 3, 4, 5. 5 multiply this angle. So we see this angle just 1 hour, like this angle. So this angle is equal 360 over 12, right? we split this circle into 12 parts. Okay, so this equal, let's see, so here we can simplify, like 12 multiply, let's say, so 330 over 12, oh, 90, 30 degree, right? Yeah, 30. Okay, so this equal 150 degree. So we also can say like this, like 3 o'clock, like this is 90 degree. So each 1 hour looks like 30 degree. Okay, so there's a problem. If the degree for a triangle are in ratio 3, 3, 4, then what is the largest one? So 3, 3, 4, we say this angle 3x, 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 that is 3x, that is 4x. Then add them together, we say this equal 180, so we can find x. This is 10x, right? 10x equal 180, so x equal 10, x equal 18. And the large one is this one, right? So 4 multiply 18. So this is the largest angle. So for triangles, we check some simplest triangle, typical triangle. So there's a typical one of the typical triangles, right triangle. So right triangle, one angle is 90 degree. Okay, so this is 90 degree or right angle. So sometimes we can write this as a right RT triangle, right triangle ABC. Okay, so for right triangle, we have a very famous fundamental theorem. Pythagorean theorem. So this theorem says a square plus b square equals c square. So here for right triangle, we call this C, this side the longest side. We call this as leg, and this side hypotenuse. Okay, so C is hypotenuse. So a square plus b square equals c square. Okay, so then we based on this we can find some typical angles, or we say we can so here we have some typical angle like 45 degree. Like if 45, if there's two sides same, if this 1, then this side, suppose this side is 1 square plus 1 square, so equal 2. So this side is like equal 2. So this is also we call it the typical right triangle 1, 1, like equal 2, and this angle is 45, 45. Or for a equilateral triangle, like these 3 sides the same, 2, 2, 2. We cut this into half, then we get a 2 large triangle. So we have this side 1, this side 2, so 1, 2. Then we can find this side that equals 3, right? So if this 1, if you don't know this, so 1 square plus b square equal 2 square equal 4. So we can say this is like equal 3. So this is 30 degree, this is 40 degree. Okay, so we say 45 degree and 60 degree, 30 degree. Those are typical angles. Okay, And for we large, so we say we have those angle 30. We can call this a 30, 60, 90 triangle. 30, 60, 90 triangle. So we have this. If this is 1, this is x, then this hypotenuse is 2x, and this is radical 3x. Okay. And the other typical large triangle is 3, 4, 5. So we call this 3, 4, 5 large triangle. And the other one is 5, 12, 13. Like if we know this side 5, if we know this side 12, then we can find this side. Let's say suppose it's C, so we can say how can we get a 13? We just 13 to come from this way. C square equal 5 square plus 12 square. 5 square is 25. 12 square is 144. So we find this equal 169. So 169, so C equal 169, take square root. So this number is happen to be an integer, equal 13, right? So we also can regard those as two typical, large triangle. 3, 4, 5, 5, 12, 13. Okay. Okay. So for a triangle, we wanted to find many things. The typical first one, we want to find the area of a triangle. So area triangle is half of B times H. So this is half of BH. So this, why we have this? This is easy. Like we can, from this triangle, we can make it like a triangle. Okay. Okay. So we can say the triangle's area equal. Let's say triangle area equal half of this rectangle, because we can say like this the same, this the same, right? So just half of a rectangle. Yeah, for rectangle, this will easy area, right? Suppose this is A, this is B, then this area equal A times B, right? Okay. So even though with this formula we can find the area of triangle, but for some problem, like if we use this formula directly, maybe this is not a good way. Okay, so let's consider this problem. Let's say we have a triangle. So there's a triangle. So point A is here. Let's say we just say we use the rectangle coordinate. 1, 2, 3, 4. 1, 2, 3, 4, like this. Okay. 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 So the triangle A is here. 0, 0. So that's the A. B is 1, 4. 1, 4. Where is 1, 4? 1, 4. 1, 4 is 1. Say 1, 2, 3, 4. Here. So this is B. B is 1, 4. B coordinate 1, 4. And C is 2, 3. 1, 2, 2, 2, 3. This is C. So we have this triangle, right? So for this triangle, if we use the formula ABC or B multiply H, so it's not So we need to find B, need to find H. So that, so we find H, find B is not so not so easy. Just take some time. But here our idea is we just use, let's say we just check this, that we just find we just regard this area equal, let's say we just check this rectangle. Okay, so this area for triangle is equal this area for rectangle minus there's three triangle, right? So for these three triangles, their area is very easy to find. So we say this area for triangle, let's say we put this A or area equal the area for rectangle. So rectangle is 2 times 4, right? 2 times 4. So minus these three triangles. So this one's half 2 times 3, right? And saying this one's minus half 1 times 1. And this one is half of this one 1 times 4. Okay, so use this way, find the areas much simple. So in many problems we just use this way. Okay, we just find some easy. We just find this triangle is area is we just minus some easy triangle, easy ones, okay, easy to calculate. So now let's consider the problem. We want to find the area for this. Okay, so here it says there's 3 multiply 4 rectangle. 3 multiply 4 rectangle. That is 3, and this is 4. Okay. Okay, so we want to find this area for this bed wings. So bed wing equals, we can say like equal this rectangle. So rectangle is 3 times 4, right? So minus this. Oh, this 2 is easy. So this is minus. So these 2 the same. So just equal half of 1 times 4, right? So it's just 1 times 4. Half. So here's 1 half 1 times 4. Here 1 half 1 times 4. 1 times 4. And then minus this and this, right? Minus this 2 triangle. So for this triangle, so this one is 1 multiply, suppose the H1. So suppose this H1, and this one, suppose it's H2. Okay. So we just need minus half 1 times H1 minus half. So here is 3 times H2, right? So we just need to find H1, H2. So we just need to find H1, H2. Okay. Okay, so let's focus on how to find H1, H2. So at the first we say H1 plus H2 equal 4. Okay. So then we need some other condition. So we say this triangle, this one, and this triangle. These two triangles. Oh, I'm sorry. These two triangles are similar triangle. So similar triangle means like, okay, we have this triangle, smaller one and a bigger one. So those two triangle we use this, like we use this notation. Look, this is a similar triangle. So for similar triangle, we have this, like this one over this one, this ratio and this ratio is same. So we have this, the 1 over here, 1 over h1. So we say 1 over h1 equal, so equal, this is 3 over h2, right? 1, like 1 is this side, this, like this, 1. 1 over h1 equal is 3 over h2. So from here we can find h1, h2, right? So let's say, so from here we can say h2 equals 3 h1. Okay, so we find h1 equal 1, h2 equals 3. So h1 equal 1, h2 equals 3. So we can easily find this the area for this bad wings. Okay, so this problem simply, like we want to find the area for this triangle A, B, C. Okay, we want to find the triangle. So we just consider, we just check this. Okay, so we just consider we just consider a rectangle like stuff from here. Okay, so, okay, like this rectangle. So we regard this triangle equal this rectangle minus some triangle. So this triangle easy, right? This one easy. This one also easy. So we just use this way. Like for this one, this equal half of 1, 2, 3, 4 multiply 2, right? And this one, half of 1 multiply 3. Yeah. But anyway, like so if we use this idea, such a problem is easy to solve. And I think this problem quite the same. So here we have a quadrilateral. So this is like we have 4 quadrilateral A, B, C, D. So A is here. So we put A is 3, 2. A is here. This is A. And B 3, negative 2. This is B. C is negative 3, negative 3, negative 2. This is C. D is negative 3, 0. The negative 3 is 0 here. So we want to find this area. Oh, this one is easy. This problem is easy, right? So this is equal, just equal this rectangle plus this triangle. Okay, this triangle. So we can easily find its area. Okay, so we want to find this area A, B, C, I. Let's say A, J, I, C, B. We want to find this actually, right? We just want to find this shared pentagon. We want to find this. Okay. So now let's check this. We find this equal. We find this area equal this large triangle minus this rectangle, right? So for this one, think is, let's say, suppose, so let's say, what is the question? So here this is ABCD is equal square. ABCD is square, EFGH is square, and this is also square. GHIG is also square. Point C and point D is in here. This squares, so we put 3 squares, put this with this D is midpoint. We just found a ratio. We want to find the ratio of the area of shared pentagon to the sum of area of 3 square. Okay, so here talking about ratio, so we can assume this square, this here, this is, let's say, this is like midpoint, so here we can put this 1, 1, okay, so here 1, 1, yeah, okay, so we can say like this, let's say, so we can assume CI equal 1, okay, and then AD equal 2, so we can say like this equal to this equal to, right, and this one, we put this point as some point, so A to here is 3, right? This is 3. So this area equal half 3 multiply 4. So minus 1 times 2. Okay, minus this rectangle. Okay, so we're talking about this ratio. This is like a shared pentagon. So then over the sum of area of the 3 square. So 3 square, so if there's a 2, so we say 2 square, 3 times 2 square. So, okay, so ratio is this. So this, let's say, so this equal, a little bit calculation easy, like this equal 6 minus 2, 6 minus 2 over 3 times 4. So this equal 4 over 3 times 4, yeah. Okay, so this is 1 over 3. The ratio. Okay. So for this problem, we want to find the area for this. Find the area of the shared part. Okay. In this 5 multiply 5. So we say this is suppose each one is 1, 1, 1, 1, 1. Like 5, 5 times 5. Okay. So okay. so for this problem, so let's say, so maybe we just put this point, so we cut the, okay. 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 So we just check it, find, so we just focus on this, we just focus on, let's say, we just focus on this part, right? We just focus on, let's say, we just focus on this. We say, focus on this part. Okay. Okay. So we say this area equal this. We say this area equal this square. This square minus this 3 minus this triangle minus this triangle and this square. Okay, so we say this area equal. We say this is 2.5 square, right? 2.5 square. So minus area for this. So we have two of them. So this equal, this is 2/2 of 2.5 multiply 1.5, right? And also need to minus this square. Okay. So let's do some calculations. So here is 2.5. You can take it out. So it's 2.5 minus 1.5. So minus 1. Okay, so this is just the 1. So 2.5 minus 1 is 1.5. Okay, so we have 4 of them. Okay, so we find this is 6. Okay, so we can stop here. This is our first video for geometry. Okay.